In this video, we're going to learn how to list the potential rational zeros of a polynomial function. Suppose I have the polynomial function f of x equals 10x to the fourth minus x squared plus 25. To find the potential rational zeros, we use the rational zeros theorem. The rational zeros theorem tells us that if we have a polynomial function that is of degree 1 or higher, where our lead coefficient, a, is not equal to 0, or a sub n, and our constant, a sub 0, is not equal to 0, and we have integer coefficients, then p divided by q is a rational zero of our function, where p is a factor of a sub 0 and q must be a factor of a sub n. So in other words, for the given polynomial function 10x to the fourth minus x squared plus 25, we assign p to our constant 25, in other words, our a sub 0 term, and q to our lead coefficient 10, which is our a sub n term. Taking the ratio of p over q, we look to find all factors of both p and q. So listing all of the factors of p, we have plus or minus 1, plus or minus 5, and plus or minus 25. Listing all factors for q, we have plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Next, we form all possible ratios for p over q. So I'll start with plus or minus 1. Now I'll write that as a ratio over q. So our first one, we have plus or minus 1 over 1, which I'll just write as 1, plus or minus 1. We have plus or minus 1 over 2, we have plus or minus 1 over 5, we have plus or minus 1 over 10. Now, beginning with plus or minus 5, we form all possible ratios, so we have plus or minus 5 over 1, which we'll just write as plus or minus 5, plus or minus 5 over 2, plus or minus 5 over 5, which we'll just write as 1, and that's already here, so we don't need to repeat it, plus or minus 5 over 10, which reduces to 1/2, and we also have this on our list already. So now we move on to 25, plus or minus 25 over 1, which we write as 25, plus or minus 25 over 2, plus or minus 25 over 5, which divides out to 5, and plus or minus 25 over 10, which reduces to 5 over 2, and we already have this on our list. Therefore, a complete list of the potential rational zeros of our polynomial function is given here. I hope you found the example helpful, and we'll see you next time.